Welcome to the Bookman's Corner. I'm Lois Lindstrom. If you have ever used the phrase, "it's not rocket science," then today you are mistaken, because it is. Joining us on the Bookman's Corner is guest author Dr. Mario Livio, who is a senior astrophysicist in Baltimore, Maryland at the Space Telescope Science Institute, which operates the Hubble Space Telescope. He is also the author of a number of books that popularize science and mathematics. He is also a fellow of the American Association for the Advancement of Science. His latest book, which we will discuss shortly, is titled Brilliant Blunders, From Darwin to Einstein, Colossal Mistakes by Great Scientists That Changed Our Understanding of Life and the Universe. It tells the story of 5 scientific giants of our time and how their mistakes turned out to be the catalyst for enormous steps forward. Dr. Livio is a popular speaker on college campuses because he combines rocket science and humor in a captivating way to update us on the latest information coming from space. His book, Brilliant Blunders, highlights the following scientists: Charles Darwin, Lord Kelvin, Linus Pauling, Fred Hoyle, and Albert Einstein. Why do you think mistakes based on creative thinking and innovation happen and are essential to making progress?
Yeah, well, first of all, we all make mistakes,
Yes.
and including the greatest scientists, and that's sort of comforting to the rest of us. But yes, it is also essential at some level to the progress of science, because you see, these great scientists, and all the ones I'm talking about are really great luminaries, they try to think outside the box.
Mm-hmm.
And guess what? When you think outside the box, sometimes you make mistakes.
Yes.
That's the nature of the beast.
You wrote in your book's preface that Brilliant Blunders is more concentrated on the thought process and the obstacles on the way to discovery rather than on the achievements themselves. Why did you choose scientific blunders related to the delicate topic of evolution in your book?
Well, you see, I wanted, first of all, to correct an impression that progress in science is some sort of a direct march to the truth.
Okay.
It is really not that at all. It is really this zigzag path with lots of false starts, blind alleys, and so on. But I also wanted my scientists to be connected by some thread.
Mm-hmm.
And the thread I've chosen was evolution. In this case, evolution of life on Earth, evolution of the Earth itself, evolution of stars, and evolution of the universe as a whole.
And it is a brilliant book, and it's been so well received and reviewed. I want our viewers to know that you received more than 54 5-star reviews in Amazon.com. How is the book organized? You have the 5 scientists, and then how did you choose to organize it?
So I really chose them in some sense almost chronologically. Mm-hmm. Because the book starts with Charles Darwin, and that's the middle of the 19th century. Lord Kelvin more towards the end of the 19th century. But then, since it started with life and life on Earth and Earth, I then wanted to continue with life and not immediately go into something else, so I went with Linus Pauling. Well, Lord Kelvin came after Darwin, then Linus Pauling, Fred Hoyle, who was one of the greatest astrophysicists of the 20th century, and then, of course, Albert Einstein,
yes,
who really is
the most
needs no introduction.
That's right, he doesn't. And now, Darwin is known most by the theory of evolution, but he didn't even use the word evolution in his world-acclaimed book on the origin of species. Please explain.
He didn't use it much in that particular book, but of course that's how his theory is known today.
Yes.
And the idea, of course, is that species are not immutable, that they actually evolve. The species we see today mm-hmm. are not the ones that always existed on Earth. In fact, most species that existed on Earth become extinct. We just see what evolved from them.
I see. Now, it was interesting to read the one question posed to Darwin about his book was, if species are so well adapted, how could they evolve and still remain well adapted?
Yeah, so he understood this problem very well, and in fact, at some level better than everybody who questioned him. This is actually the idea of natural selection, that they are well adapted, but they are well adapted through a whole series of steps. I mean, it's not that at every step everything is already perfect, and in fact, the whole concept of evolution is that nothing is perfect even at the end. Mm-hmm. I mean, because evolution can only work or natural selection with what already exists.
Yes.
So you see, if I were to, create a human from scratch now, I might have chosen a different type of design, maybe one in which you have 360-degree vision, and so on. But that's not how it worked. Evolution just tinkers with what exists and changes it a little bit for the better.
Well, now, does Darwin discuss the actual origin of life as well as write about the evolution of the universe as a whole?
No, he did not. I mean, he definitely talked about evolution of life on Earth, but he did not discuss what the universe is doing, which he really couldn't because he was extremely weak in mathematics.
Oh, really?
Yes, and also he did not discuss the origin of life per se. I mean, how did life actually start? That he did not discuss. He did say that all life on Earth evolved from one species, probably at the beginning, but he did not discuss the actual origin of life.
Yes, it didn't elaborate. Well, what was Darwin's greatest blunder?
So his blunder had to do with genetics or heredity. Now, nobody used even the word genetics at the time because it didn't exist.
Okay.
Namely, the characteristics of the mother and the father get mixed together like you would mix paints. So he adopted that. What he did not understand, and that was his blunder, is that if that were the correct theory of heredity, then natural selection could never have worked at all. Because let me try to give you an example. Suppose I have a million butterflies, they're all white, there is one black. And suppose that being black gives you some advantage. According to natural selection, that would have meant that after many, many generations, the whole population of butterflies should turn black. With blending heredity, the black butterfly mates with a white butterfly, they produce a gray butterfly. Black is gone. The gray butterfly would mate with another white butterfly, would produce an even paler shade of gray, and so on. You very quickly would get even more than 50 shades of gray, and black would certainly disappear. So he didn't get that until it was pointed out by an engineer, Fleming Jenkins.
Okay, interesting. Now, Darwin's theory of natural selection should not have worked given the prevailing beliefs of the time. I mean, what were those beliefs and how did Darwin succeed?
So I just described, the belief was this blending heredity. And the blending heredity could not have worked. I mean, everybody who, drinks a gin and tonic, if you'll keep pouring tonic into it, then at the end you will not feel the gin.
That's right.
So it doesn't work like that. The way that genetics works, and we know now after Gregor Mendel, is it's more like shuffling cards than like mixing paints. When you shuffle cards, the individual cards remain. You see, if you have an ace, and having an ace is great, it doesn't matter how much you shuffle, you still have the ace.
The ace is still there, yes.
Right. While with paints, if you mix the paints, the original color is gone.
That's right.
So that was the difference, and only after this was pointed out, he got the idea that this was not working, but he couldn't quite work the correct theory.
The card description pulls it together there.
Right.
Now, how many species are there, and how has this changed since the Earth began?
Well, we don't exactly know how many species there are. Estimates are anywhere between 5 million to 100 million.
Five million to 100 million?
Yeah, very careful estimates try to put it now at about 8.7 million, but we don't know how accurate that is. You see, the point is that you take 1 teaspoon of dirt from under your feet, there are already thousands of species there. So that's how it works. Now, how has it changed? Well, at the beginning there was one. So one or a couple started from chemistry, and then, they started
That's
evolving.
right. Well, I found the genetic drift fascinating because as it relates to the Amish people in Pennsylvania, because some of them have a recessive gene which gives infants extra toes or fingers. Amish marry within their own group, and 200 of them arrived in the United States from Germany in 1744. Well, please discuss genetic drift.
Well, genetic drift is really a trend that is not the main trend, perhaps, of the way genetics works. The main trend still works via natural selection, but you can have, especially in small populations or relatively small populations, you can have these situations where things can be influenced very strongly by particular properties, and because it's a small population, this thing shifts through the population. So the example you gave with the Amish is indeed that they tend to marry within their own.
Yes.
As a result of this, we can actually trace this idea of having, perhaps 6 fingers, for example, actually to one couple, that arrived. We can trace it back, and because it stays within this thing, then this become more prevalent than in the population in general.
Well, that's fascinating. Now, Lord Kelvin, who lived and worked in England, died in 1897, and he was dubbed the dynamic Victorian. He computed that the age of the world's crust at 98 million years, and he also developed a scale to measure temperature. Tell us about Kelvin's scientific background.
So Lord Kelvin was the most prominent, I think, physicist of his time.
Okay.
He was one of those people who could do it all. I mean, he was a physicist, he was an engineer, he did things from theoretical work to practical things. He developed things for sailors, and he was involved in the cable that runs under the Atlantic Ocean. He was involved in many such things. And he actually did the first bona fide calculation, attempt at calculating the age of the Earth. Where you think about this, how would you go about calculating the age of the Earth?
Yes.
And he had this brilliant idea where, everybody kind of believed that the Earth was formed hot, and it's cooling ever since. So he said, well, in that case, I can use, it's a bit like forensic, when the pathologist comes and determines the time of death from the temperature of the body, and so on. So it determines how much time has passed. So he said, if I will measure how temperature changes with depth inside the Earth, I can thereby determine the age of the Earth. And he did that, came up with a number that was about 100 million years. We know that the Earth is actually 4.6 billion years old. So he had it wrong, but at least he had a very interesting idea of how to attempt to estimate that.
Well, was that his biggest scientific blunder, that he had it wrong, you think?
I don't think it was, in every case of one of these scientists, I only chose one blunder and concentrated on this. He did other blunders. I mean, at one point he declared that physics is essentially done, and there are only 2 small problems that remain to be explained. One has to do with heated bodies, and so on. And it turned out that those 2 small problems that he thought that they were just small things, one turned out to lead to Einstein's general relativity, and the other one turned out to lead to quantum mechanics. So basically to 2 of the greatest revolutions in science at all. So, he was wrong on a number of accounts.
Okay. Now, next you discuss the work of chemist Linus Pauling, who received 2 Nobel Prizes for developing the model of proteins. Now, why are his discoveries important?
Well, Pauling was the greatest chemist of his day. He understood the importance of what we call the hydrogen bond, which is, when a hydrogen atom connects to 2 other atoms and holds things together and so on.
Part of in water, H2O, right?
and plus, he came up with this model for proteins, which is still the correct model, and so on. He was very influential at his time. He was also happened to be a great pacifist. He got the Nobel Prize for Peace also, and for chemistry. So he was certainly one of the most respected scientists at the time.
Was he involved at all in genetics with Linus Pauling?
Well, he tried, after finding this model for proteins, he actually tried to develop a model for DNA. DNA, is this all-important molecule that is responsible for everything in genetics. It's the one that's responsible for replication and for the transfer of properties from one generation to the next and so on. And he tried to come up with a model for that after his model for proteins. And his blunder had to do with the fact that he came up with a completely wrong model for DNA.
Oh, he did. And so they were chromosomes that were on the...
No, it was not at that level. No, it was not that. DNA is composed of three main things, which is sugars, phosphates, and four bases. And the way it is constructed is that the bases actually are at the center and they connect to each other in a certain way, and the others are on the outside. Pauling constructed a model that had the wrong number of strands. It had 3 strands instead of, we know that DNA is a double helix. It only has 2 strands. And plus he put all the phosphates, he put the phosphates in the middle, but the phosphates are actually have a negative electric charge, and negative electric charges repel each other.
Yes.
So actually his model, the molecule could not have been held together.
He was a very prominent cosmologist who wrote that our universe is never changing, and we know that idea is wrong. When and how did he learn that he was incorrect?
So you're talking about Fred Hoyle now.
Yes, now I'm talking about Fred Hoyle.
Yeah, Fred Hoyle was a cosmologist and a great astrophysicist. He had this steady state model, that the universe was always the same, will always stay the same. There is great elegance in that model, you know, a universe that never changes, you know, and so on.
It makes people feel very comfortable, I think.
But, you know, we know today that our universe actually started with a Big Bang about 13.8 billion years ago. So our universe is absolutely changing. And unfortunately, Fred Hoyle, as smart as he was, stubbornly persisted, you know, with his model, and even in the face of much evidence that accumulated, you know, that the universe has evolved, he refused to accept that, and that was his biggest blunder.
So that was what he just didn't believe in it. Why didn't he believe in it? You think his ego was so big, or?
No, well, that's part of it, but I don't think that's the whole story. I mean, there are many ways. So first of all, he liked this steady state model, and I must say that had not the evidence shown otherwise, I like this model too. It's a great model, but it's very elegant. But he also had some ideas actually about the development of life, and he thought that life is so improbable, that the processes that lead to life are so improbable, that having a universe that has a finite age, you know, 13.8 billion years, however large that age is, just would not have been enough for life to actually appear. And he wanted to have a never-changing universe in which you have all the time in the world for life to appear.
Now, you write 2 chapters on Albert Einstein, who is one of the most popular scientists in the United States, although he was from Germany. Didn't he set up the foundation for physics, or partly?
Well, the foundation for many areas of physics.
Many areas, okay.
Yeah, so first of all, his theory of special and general relativity changed all of our notions of space and time and gravity and all that, and what they do, of course. And besides, he did some work on Brownian motion, things that on the photoelectric effect, for which he got the Nobel Prize in Physics, which actually was the beginning of quantum mechanics. So he certainly was one of the founding fathers of many areas of modern physics.
Well, I think it would be fun to review the gravitational force with your keys. If you throw your
keys,
if you throw your keys up at a speed exceeding 7 miles per second, they would escape the Earth's atmosphere.
Correct. So you see, I throw my keys up, and you see them slowing down and even coming back. Now that is because the Earth has gravity.
Yes.
And gravity slows the keys down and brings them back. If I throw them fast enough, however, if they exceed something we call the escape velocity, which in the case of the Earth is about 7 miles per second, then, you know, gravity would just not be able to stop the keys, and they would just go on forever.
Whoa, that's amazing. And of course, would the keys float in the air? They would not be suspended at all.
No, keys would not float in the air. I mean, keys, for something to float, and that's what Einstein wanted at some point. You see, he thought that the universe is static.
Okay.
That, you know, everything stays in place.
Okay.
He didn't know about other galaxies at the time. He only knew about stars, but he thought that they are all static. He thought that was a more elegant universe, that everything is in place. Now, for things to stay in place, they need to be in equilibrium. But gravity, you know, says that every little bit pulls on every other bit.
Yes.
So, well, down is meaningless in the case of the universe, but it would all collapse.
Yes.
Yes, I mean, because everything
Pulls
on everything else. So he suggested that there may be an attractive force, a repulsive force that precisely balances the attractive force so that everything stays in place. Like imagine, you know, if my keys, if I'll take them out again, okay, the earth attracts them. But if there was something that repelled them also with exactly the same force, then the keys would be hanging in midair. So he wanted to have something like this, added this repulsive force that would keep the universe in equilibrium. That's what he wanted.
Well, I think it's fascinating that Einstein did not know about other galaxies in the universe during his time on Earth, but Hubble confirmed that the universe is expanding. Now, you work on the Hubble telescope. Can you briefly give us a background information on Edwin Hubble and his contribution to science?
Yes, let me just only make one small correction. I mean, Edwin Hubble made this discovery when Einstein was still alive. So Einstein did learn that our universe is expanding. Yes, he originally didn't know about that, but
he did learn. Yes.
Yeah, Edwin Hubble was an astronomer, and he is the person who discovered that our universe is expanding. He basically showed that every distant galaxy he looked at is moving away from us, that the universe is expanding. He also is the person who was the first to show that there are galaxies other than our own Milky Way galaxy. He is the person who classified galaxies in terms of their shapes and how they are. So he was really a very, very dominant figure in astronomy.
Fantastic. Now, you wrote that scientists have discovered that the cosmic expansion of outer space is not slowed down over the past 6 billion years, but it's speeding up.
Correct.
How do we know this?
So in 1998, we discovered, you see, we thought, okay, the universe is expanding, very nice, but maybe gravity is still slowing it down in the same way that the gravity of the Earth slows down my keys. In 1998, two groups of astronomers discovered that not only is not the expansion slowing down, it's speeding up. Something is pushing on them, you know, to actually accelerate. So our universe is accelerating. And the thing that makes this acceleration, it turns out, is, at least as far as we know today, may be exactly that repulsive force that Einstein first added to his equations and then took it out. So Einstein's blunder, if he made one at all,
that was my next question.
Well, was not to add this repulsive force, but to take it out, because we now know that it's actually there, and the universe is actually
accelerating. What is your major takeaway from your research into the lives of these famous scientists?
There are a few things. So one of course is the fact that even the greatest scientists make mistakes. But the more important one is the one that I mentioned earlier, which is that in order to make truly great discoveries, you need to think in unconventional ways or outside the mainstream. And this is what all these 5 scientists have done. But that when you do that, you have to accept the fact that sometimes you make mistakes. So the mistakes become part and parcel of the whole scientific progress in that sense. That is the most thing. And this is why I distinguish between, you know, I call the book Brilliant Blunders as opposed to Sloppy Blunders. Brilliant blunders, I call those things where people really try to think outside the box, and because of that may make mistakes, as opposed to making mistakes because they are not thoughtful enough, or you know.
But they made major scientific contributions, didn't they?
That's right. Each one of those mistakes eventually, you know, opened the door for new breakthroughs.
Well, another thing I would like to ask you is, do you think extraterrestrial intelligent life exists? You asked this question in your book because it is one of the most intriguing questions in science today. And what do you think?
Well, I think that surely they exist, yes. You see, what we have discovered in recent years is that there are in our own galaxy, just the Milky Way galaxy, there are probably of the order of 1 billion Earth-like planets that orbit their stars in what we call the habitable zone, which is that zone which allows for liquid water on the surface of the planet, which we think that that may be a necessary condition for life. So about 1 billion like those in our own Milky Way. Now, in addition, the Hubble Space Telescope has told us that in the observable universe alone, there are a few 100 billion galaxies like the Milky Way.
Incredible.
So it is very, very difficult to think that in all of this, we are the only life that exists. Now, it is very possible that in most cases, life has not advanced beyond some relatively primitive form, and so on. But it is also possible that in some of these cases, life is much, much more advanced than we are. And I, prefer to think that that's probably the case, that we have a wide range of life forms, some that didn't advance very much, some that probably are much more advanced.
Aha. Now, are you working on another book?
I always work on another book. I mean, at any given time, I work on another book. Well, but I cannot tell you what it is, or I have to kill you.
Okay, I understand. Well, unfortunately, we're running out of time. I just want to ask, where can our readers in Arlington find your book, Brilliant Blunders?
Well, hopefully they can find it in any bookstore. And of course, also in Barnes & Noble, on Amazon.com, and so on. I mean, I would hope that every bookstore has some copies of the book.
And do you have a website?
I do have a website. It's mariolivio.com.
I see.
mariolivio.com.
Okay. Well, it's been fantastic. Thank you so much for being on our program. And I just feel like I've been talking to one of the best science writers in the galaxy.
Well, I don't know if that's true, but I'll take it as a compliment.
And so I hope to have you back, and thank you for watching. Please join us again next month for a new edition of the Bookman's Corner. I'm Lois Lindstrom.